everybody. Thanks for joining again. My name's Troy Daniels, Head of Technical Training here at SimpliPhi Power. I'm going to be giving this presentation. It was originally supposed to be Matt Walker. He is at NAPCEP today, or in the air, probably traveling. So I'm going to give this presentation myself. Bear with me, as this is not my presentation created. So I've practiced through it, but it is not my presentation. But we should have plenty of time, as I think I'll probably go a little faster than Matt might have through it, and have plenty of time for questions. So what is our training about today? Why the battery management system, BMS, matters, and understand the difference in certain BMS functionality. And we'll kind of relate all of that back to our products and really looking at the SimpliPhi versus the Phi batteries and really understanding some of the kind of key differences, as well as maybe why one fits a specific need over another. A little bit of housekeeping. Just an FYI, if you are looking for the Q&A bar at the top, you can actually see that Q&A. You'll see, you can type any questions into that as you need throughout the presentation. And again, I'll carve out some time at the end. I won't probably be answering questions as we go along. I'll probably wait till the end, and then we'll knock out all the questions out at once. All right, with that being said, let's jump right in. So we're going to kind of start with kind of some fundamental questions, and that is, what is a battery management system? I think that we could probably argue a million different definitions. We're going to kind of keep it basic on the definition front for this end. And really, again, we're always kind of talking about how it relates to what our products are doing. So while there might be, 10 different definitions to a battery management system, and BMS, just get used to that word. I'm going to say the word BMS more than not compared to battery management system. But we'll just kind of look at some of the fundamentals of a battery management system. So a BMS is basically the brain of a deep cycle lithium battery that manages and protects the battery from functioning outside its safe operating parameter, monitoring various environmental and system-based conditions, and calculating secondary data, and maintaining proper self-balancing. It's kind of important to always think that while those are kind of the key features of a battery management system, not each of them operates the same way, meaning a protection that's built into one BMS might not be the same as a protection built into another. Some are more advanced, some are less advanced. It's just the way it goes as far as, BMS having different functionalities, just the same way as an inverter or a charge controller would. The main purpose, it could be argued, of the BMS is to protect the battery from damage and ensure the battery has access to its full capacity. Now, I would kind of make the argument, if anyone took my training last week, we actually had this slide on, we talked a little bit about it, and I'm going to touch on it again. That's, to keep in mind, while that is kind of the primary function of a battery management system, I think we're seeing more and more movement towards advanced functionality. And I hate to say the word just kind of cool functionality, but that's the reality, is some kind of cooler things that we're using the battery management system for, to kind of get some more intuitive data, better reporting, and even functionality within the battery. So while the protection will always be there, I think that's kind of the base function, and we're pushing the limits of what a battery management system can do more and more. So are battery management systems required for all batteries? They are not. BMS are not required, technically at least, for any battery to work. A battery will work, even a lithium battery can work without a BMS. As I think probably many have found, trying to implement a battery management system or a lithium battery without a BMS does not work very well, will not hold up very long. And definitely the life expectancy of the battery is going to go down significantly, as well as the functionality and kind of thresholds of that battery. Lead acid batteries typically do not need a BMS. They could benefit from one, but again, it's just really not that benefit. It's not enough benefit to want to put battery management systems into a BMS. Lithium batteries, the BMS improves the performance and safety of the entire lithium battery. So it ensures full capacity is available for each cycle instead of being limited by weakest cell. That's the functionality of the BMS, actually taking in that cell data and understanding where resistance might need to be changed, protects the battery from abuse. Again, that's kind of that safety factor. And even in some cases, it can help prevent thermal runaway. We use lithium iron phosphate, so the BMS might be there to help with that, but really not as much as it might be there to help when it comes to cobalt-based lithium batteries that do require that and are really prone to thermal runaway. Okay, so wiring, kind of just giving a general example here. Really basic level stuff. I think if we look over here, we see our positive output, our negative output terminals. We can see where the actual board is, and we can kind of assume the FETs being here. You can see C negative, B negative, and this is where the connection again to these cells. This is a representation. These are, let's say, 3 something volt cells typically. 3.25, I believe, is pretty typical with LFP. And these are the cells that actually make up the battery itself, and they're all connected to the BMS. You often have balancing wires. You might have a cell card at the cell level, or you might not. It kind of depends on the battery management system, and also depends on the size of the battery. I worked for a while with large amp hour battery cells. We're talking 2 to 1,000 amp hour cells. Those required basically a balancing card at the cell level. That's not always the case, and oftentimes the BMS can handle it all on its own just from this connection point here. You'll probably have some comms ports if that is part of the BMS's functionality, and that's kind of just the general wiring diagram. Some do not have temperature sensors, and even resistors related to temperature, as our SimpliPhi does. Thermistor, basically knowing when to open and close a circuit based on temperatures. Some have no temperature sensor at all. That can be pretty common as well when it comes to analog BMS. And a BMS uses contactors or FETs to open and close the circuit. A BMS will typically not throttle current. It can tell devices to throttle current with comms, but it itself does not throttle the current typically on its own. So let's kind of dive into types of battery management systems. And I'm going to kind of keep it simple and just look at really the difference in the analog and digital BMSs and really on the surface level here. So basically an analog BMS does not have a user interface. So programmed during the manufacturing, if at all, sometimes they're so basic they don't actually need programming beyond just basic circuitry work. So, but for the most part, most BMS do have some sort of programming, even if analog, that is done typically in a factory setting before the battery management system, maybe even is put into the battery itself. It's made up of hardwares. We mentioned FETs, resistors, and diodes. And performance is really based on electrical signals, not the communication. So again, that's kind of that basic electrical properties of the analog BMS versus the more complex digital BMS. It relies on the values of those components to take or not take action, like opening and closing a switch. So basically, basic circuits, open, close, and just understanding what the parameters are around that. And for the most part, these do not transmit data to other system equipment. So it does not have communications built into it. I'm sure there's an example where maybe that isn't the truth, but really if it's analog, it shouldn't have any digital portion to it where it can communicate to the device. So it's a more basic design that doesn't make it worse. I've always kind of said that. I think that there's a reason and rhyme for each BMS to make a lot of sense. So we'll dive into that when we talk about the specific products that use these, but it's important to know that just because it is more basic design does not make it something that is worse. Oh, sorry there. All right, jumping back. Okay, now let's look at digital BMS. So digital BMS usually have a user interface and communications. I know it's the same picture, but kind of give an example of basically we're looking at software and electronics here. They're programmable, may or may not be reprogrammable in the field. I know as far as like our amplify, why we don't want people messing too much with the internal workings of that digital interface. There are some advantages to being able to connect directly into the BMS in the field, and that's a huge advantage to digital BMS, whether it's pulling data or making slight adjustments that are allowable. Takes digital input and converts to electrical signals to take action. So instead of that kind of just basic, circuitry doing its own job, there's kind of a hive mind here that makes those decisions and converts it to an electrical signal to actually make those actions count. May or may not transmit data to external equipment. Typically, almost always yes. As long as the communication is built between the two devices, it's going to be submitting data. It's important to kind of note there's a difference between submitting data, though, from a digital BMS and a BMS that is actually telling the system what to do. For instance, our amplify is a closed loop communication, meaning that it does not only just report data, it actually has the ability to send signals to things like the inverter and the charge controllers and whatnot, and actually update set points and different thresholds as it sees fit, which is a huge advantage when it comes to kind of ease of installation and just safety factor within a design of a battery system. Batteries with a digital BMS may also have an analog BMS as a failsafe, super common. And I know one particular battery of ours that has exactly just that. It is a huge help to have both oftentimes. The other types of BMS we might look for are low versus high voltage BMS. So low voltage, an interesting thing to talk about first and foremost is low voltage BMS, why we can't put those products in series. And really kind of like, let's look at the reasons why. If one BMS senses the battery is too full and open circuit, any battery in series would also stop charging. So that could definitely cause a ton of issues. If one battery is in a series connection of two open circuit, the full voltage of the stack would be applied to location where the circuit is open. So that would cause a ton of issues. The BMS prevents the cells from overcharging, balances the cells, and performs other tasks to ensure that the batteries are maintained correctly. Once the cells are fully charged, the BMS will go into open circuit to prevent further charge going into the battery. So we can, again, these are issues that if we have a low voltage BMS and we're trying to put batteries in series, it's not going to work correctly. If the device used to open the circuit is not able to handle that voltage, it will be damaged. That's a huge one. I mean, we're talking basic circuitry that cannot handle that voltage. So this is why with our low voltage BMS, we don't want to put those batteries in series. We want to put them in parallel. We want to keep the voltage the same. That being said, there's solutions to the other way if we want to go in series, and that'd be a high voltage BMS. Series connection requires the BMS to contain different hardware, having bigger thresholds with that voltage. A stack controller actually coordinates the readings from all modules to make BMS protection decisions. And the stack controller hardware can handle the full stack voltage. So there'll still be a range on it, but it's something that we know the range and it's much wider than if, we're talking maybe with a low voltage BMS, let's say plus 20, minus 20, if even that sometimes. And high voltage, we might be talking 200 volts DC to 1500 volts DC as the range. Each individual battery within the stack does not have a BMS, but only a cell measuring and balancing device. Very similar to like a cell card is kind of how I would look at it when we're talking about like very low, smaller BMS designs. And this might read temperature, but it also is what's functioning and balancing the BMS. So that is a high voltage BMS. We're going to talk a little bit about, we do actually offer commercial products with something like that. But for the most part, low voltage BMS will work just fine with any residential or smaller scale products. Excuse me. So why are battery management systems important? So let's look at cell balancing and protection. I personally think cell balancing is probably one of the biggest functionalities of a battery management systems. I would say it's the biggest necessity of where the battery management system really derived from. Passive cell balancing balances cells at the top of each charge cycle. If any cell finishes charging before the others, the BMS basically forces it to dissipate some excess power as heat. So it bleeds off resistance, you could say. It basically has that kind of bleed off current. It's super small typically. So like scale power right there, you can see 0.1 amp. They're tiny amounts. And you need to kind of keep that in mind. So that, again, I mentioned like large scale cells actually don't work the greatest. Small cells are really nice because they have very small need for bleeding off resistance. And that passive cell balancing can do it just fine from when it comes down to that very small, maybe we're talking about, very like, let's say a 10 watt hour cell or something along those lines. That's probably plenty of balancing current. We can also look at active cell balancing. So actively pulls power from one cell to charge another cell. So there's not that kind of heat dissipation there. It's more just that it's actually using that overcharge to charge a different cell. This still usually only occurs when there are voltage difference in the cells, which would be at the top of a charge or bottom of a discharge. Typically not in the middle there. It's great for second life cells that have different capacity remaining. So it can definitely be a little bit more intuitive and can help out a lot when we have maybe like a second life battery. Can be used in conjunction with the passive cell balancing as well. And this is usually larger scale. So again, if we're using like large, let's say, 200 amp hour cells, this is probably what we need, is that active cell balancing. 1 amp, that's a lot of balancing capacity. Still small scale though, compared to charging rates. Okay, now very briefly, protection with closed loop versus protection with analog. It's always important to look through. Both BMS and programming on the analog side work together. The BMS does not modify charging currents or voltages, but it can communicate with the external equipment to ask the equipment to modify the charging specifications. This is kind of what I was discussing when I was kind of talking about closed loop versus just simply reporting data from the battery management system, is the ability to basically say, hey, I know I don't want to charge that much. Here's the data that I know my battery can handle, and it sends that data to the equipment itself. BMS will not limit load, but can, again, communicate with external equipment to ask equipment to limit the load itself. Works with the inverter and chargers and other equipment, as well as it also works independently. Usually collects and reports data as well. I know ours does for sure, and does the communication side of things to the equipment itself. Protection with internal analog BMS. Really, these are working independently of other equipment. It's really mainly there to prevent disaster and serious misuse, not designed to be an only line of protection. So that being said, if you're working with a battery that has an analog BMS like our Phi, you can't just throw the battery in and expect the battery management system to do all the work. It still requires programming and making sure those safety programming is still put into place. It's really, again, it's more there as a last resort, and we don't want the BMS to have to do its different protection triggers, as it always will not be very satisfactory on the battery's health. Okay, let's talk a little bit about programming. So basically understanding program and design when it comes to how it's related to BMS. I just want to take a quick pause here. I see a lot more people have come in since I first started. We should have plenty of time at the end for Q&A. So if you have any questions, if you didn't hear me when I first mentioned, you can go to that Q&A section. It's on your control bar and type any questions in. We'll happy to get around to them at the very end here. All right, so back to programming. Internal analog BMS with the Phi battery. So this is our analog BMS. And what does that take to programming? I kind of just alluded to it a little bit, but basically programming the external equipment is the main source of protection. The battery management system is not that main source. And the BMS alone does not provide warranted protection. It's similar to another battery. We want to program things. We want to program things like low battery cutout. We want to program things like charge voltage, max charge current. The 2-to-1 ratio, which you've probably heard me harp on a million times if you've taken any of my other trainings, we really want to make sure that the inverter does not over discharge the battery and that the batteries can handle the entire inverter's output. Make the batteries, if the batteries are, let's say, or the inverter's 8 kilowatts, the battery should be 16 kilowatt hours. That analog BMS, again, is not the main source of protection when using the Phi batteries. The programming itself is. The SimpliPhi is much different. The SimpliPhi has closed loop communications and can actually auto-populate set points. So the most crucial settings are automatically programmed. The SimpliPhi BMS can identify bank size and adjust settings accordingly. I just want to make sure I'm making this clear, though. This is when it's connected to an inverter that it does communicate with. Right now, that's the Sunny Island SMA and the Solarc, I believe, any model. Those are the ones that it does communicate with. You cannot just hook it up to any random inverter and expect the protection to be there. But when it is communicating with the inverter and the chargers, it can identify things like battery bank size. It can automatically adjust set points. It knows which settings can be changed and which cannot, and how high those can be changed or how low they can be changed. So it is kind of dummy proof, in the sense that it really makes sure that it never exceeds its own thresholds. And that is the digital BMS that is inside the SimpliPhi battery. So let's talk about SimpliPhi products a little bit. So the standard Phi products, this is what I was just talking about. This is the internal analog battery management system. So this is things like our standard 3.8. I know this picture is actually wrong now. We don't sell them in the black case anymore. These are in the white case. Actually, this is wrong too. This is now in a new case as well. But this is the 1.4 and the standard 3.8 Phi model. This comes with the internal battery management system that is an analog BMS and does not have comms built into it. The Phi battery line does not have communications and do not require battery-to-battery connection for proper installation of functions. I mean, there's no CAN lines running from battery to battery, as it really kind of does its own thing. The Phi batteries can be scaled up to meet any energy or battery demand and do not have a maximum limit for parallel connections like many COM-based batteries. Moving on, the SimpliPhi. This is our closed loop communication with inverter, populated set points, advanced integration with the Solarc and the SMA Sunny Island inverters. Again, auto-populates the set points, high level protection, high level accurate readings as well, like state of charge, voltage, charge and discharge. The flexible sizing, meaning it knows how to limit its own discharge through the system itself. So you could have maybe two batteries on a 12 kilowatt Solarc, and that's okay. And really that plays a lot when it comes to scale factor. We also offer high voltage batteries. These come with a high voltage external BMS. This is the one I was talking about regarding, full stack controller with that communication built in to handle those higher voltages. Ours is specific for 200 to 1,180 volts DC nominal. That does not mean that you can't go higher. You can charge higher. That's just the max nominal voltage. Each battery module is connected to the stack controller, BMS in the switch gear. So this being the stack controller here, and these being the actual modules. and this kind of being that card run there where each one's connected. Cell interface maybe either internal or external to the module case. And interestingly enough, this one has battery monitoring built into the BMS itself. So being cloud-based where it can actually communicate different health factors or statuses of the battery directly from the BMS itself and not coming from the equipment it's connected to. So definitely when you're talking about large scale multi-megawatt hour installations, that's a huge benefit and something we always want to stick with to be able to monitor direct. So why choose one product over another? I'm such a strong proponent here that I think we're going to wrap up here before we go into kind of questions, but I just want to kind of end on some notes around this where I really think that there's a reason and a rhyme for each battery. You know, not every system might need communications. Let's say you're doing an off-grid lead acid replacement. That's a great time to just have the standard Phi battery. The warranty is the same. It's going to hold up really well. There's probably not comms capabilities that need to be put into that system. And it's a great solution. It's a little less expensive, so you'll save some money. So if you don't need those comms, you can save some cash. Grid tied and monitoring, oftentimes I see these with, you know, this could be Phi or this could be SimpliPhi. This depends on customer preference. You'll see some customers that really want that advanced grid interaction or maybe really advanced monitoring. That's a great time to go with something like the SimpliPhi, where it has that data that's submitting right to the battery itself or to the system itself. It's the highest accuracy data we can get out of the battery because the battery is reporting it directly from itself. C&I projects, maybe it's high voltage. We might need something like a larger high voltage battery, which really was going to have an advanced BMS on it no matter what, just due to the nature of the product. So there's kind of a rhyme and a reason for each product. Again, I always say that you can't just say one has comms and one doesn't, so one's better than the other. I think it just depends on the application, and I always stick with that when trying to decide on which battery makes sense. There's no point really always in wasting cash on something you don't need. All right, just to wrap it up, I want to give a little plug to our Elite Installer Qualification Program. We have a lot more people joining this program, so jump on if you haven't already. Basically, if you're installing our batteries already, this is a great program to join. If you sign up, you end up on our Where to Buy map where you can be seen as an installer that's gone through this program. We actually run contests now. So we do the IQ photo contest each month. You can apply for that any month you want, up to $250 in cash. 250 towards batteries, actually, I believe, from that photo contest, as well as $25 cash back per battery just for being part of the program. So every battery installed comes with that $25 cash back per battery. So you'll actually make a little money back. If you sign up for this program, you'll have a lot more marketing that will happen around your company from our marketing team through our social media, as well as end up on this Where to Buy page. So definitely check it out if you haven't. This is a little bit about our photo IQ contest. Rolling entries, which means, if you don't win one month, you might win the next month. Follow this link. Application takes no more than 10 minutes. And one of our trainers will guide you through the rest of the process, get you all signed up. So if you're already installing our batteries, please follow that link, get all signed up. And it's a really great program and some more features hopefully coming down and better incentives. We'll just continue to grow on this program. All right, I'm going to pop open the Q&A and just see what questions we have. So this is now the time. Be good to write in any last minute questions you have. Why did you show a Sunny Island inverter and not a Solar? I didn't know that I did that. Probably no rhyme or reason. Let's see what we're talking about here. I didn't even know I showed a Sunny Island, actually, interestingly enough. Not sure I even see a Sunny Island, but no preference one way or the other. They both work with the SimpliPhi battery, and both can be connected with the SimpliPhi battery, and hopefully much more inverters to come. We're working on a few other brands that we're going to be connecting to as well. How well do lithium iron phosphate batteries handle vibration in mobile use? Is there any problem using them with the mobile inverters? Not really as much on the chemistry as much as just the battery design itself. All of our batteries are rated for mobile applications. We have tons of different batteries that are used. I prefer the 1.4. It's a little smaller, more compact. So that's the one I typically would recommend when it comes to mobile applications, but they are all rated for mobile applications. Can you use lithium batteries without a BMS? Yeah, as I mentioned in that one slide, you could. Your battery's not going to last very long, though. They really need them to kind of tap into that full potential and that full longevity of the lithium battery. What popular and available charge controllers work well with and are set up easily for lithium iron phosphate batteries? So with our batteries, check out our integration guide page. You'll see a bunch of ones that we know work really well with our batteries, from Magnum, Schneider, Victron, Solarc, SMA. I feel bad because I probably missed one, Midnight, Outback. All of these are ones we've kind of tried and true with our batteries. If you're looking at the SimpliPhi specifically, again, use the SI or the Solarc. What is the recommended absorption time for this lithium battery? Typically 6 minutes at 56 volts. But really, I've moved a lot towards end amps. It's actually interesting if you look at our SimpliPhi battery, it does it based off end amps, meaning that end taper current. So it doesn't even need to worry too much about time. It does it based off of what it knows, where it knows it's at, and how much it needs to keep going. All right. Let's see what else we got here. Is the Elite IQ program running in Africa as well? Absolutely. Runs all over the place. So all over the world, not just a US based. We actually, I think, might even have a few IQ installers in Africa already. So definitely go check that out if you're interested. Or just email me at training@simpliphipower.com. We'll help you get you through the program and all the info you need. Can you remind me of the minimum operation and storage temperature? -20 on the operation. Oh, excuse me. Sorry. 0 degrees on the operation. That's Fahrenheit. And I believe it's -20 on storage. I don't actually know that one off the top of my head, but I believe it is -20 on storage temperature. Let's see. Slide with the Connects SCP. I'm not sure. I'm going to skip over a few of these here. Do the SimpliPhi batteries communicate with the Victron Quattro inverter charger? They do not so far, but that is actually one that I know is in the docket to get all set up. I love Victron stuff personally, so that's one we're actively working on. All right. Please clarify the lithium-ion versus lithium-iron technology. Well, lithium-ion is really more the encompass of lithium chemistries. So you could have your lithium-ion be, cobalt-based lithium like Tesla, or lithium iron phosphate like we use. These are just different types. So lithium iron is just the specific different type. It has to do with the anode and the cathode that we're actually using within that battery. Lithium iron phosphate holds a lot of advantages. It's not prone to thermal runaway, and it's shown to have a really long lifespan. Is the higher volt battery available on a customer basis? Can the higher volt battery be configured to work with Solar Edge? So Solar Edge is really more for residential side, so I would not recommend using the higher volt battery with that. It's really designed for C&I projects, not to work with that Solar Edge. I also don't think Solar Edge really recommends anybody except for LG, and I think they're new batteries. So we don't really pair with them as far as that system goes. Came in late. Can you email me recording the webinar? Absolutely. It'll actually go out after fairly close to after this. We get automatically sends out the recording. How basically this customer is saying, oh, I have 6 batteries working great for a year and a half. How can I calculate the degradation? If any of the battery bank, I use my Midnight Whizbang Junior to evaluate SOC. It's a good method too. I mean, honestly, just running like a voltage, maybe like watch the voltage on a discharge. So, use like a very, very constant discharge. Maybe like you can find like I don't know, depends on how many batteries you have, but like, let's say a 200 watt to 1000 watt hour, or excuse me, watt load, you could definitely kind of just watch that voltage drop as you discharge. That'll give you some good ideas. Are there any installations with the UK TESUP small wind turbine? Not super familiar with that one off the top of my head, but send over the specs and we're happy to take a look and see if it all works out. Awesome. We're installing 100K. That's great to hear. Love it. And then I've got a question to go back to a slide. Happy to go back to a slide. Looks like this slide here. Again, this slide is more just related to, I'm not going to go through the entire thing again, but this is related to basically when using the internal analog BMS, so the PHI products, really we want to make sure we're programming the inverter more than anything, not relying on just the battery management system to use protection. So you're looking to install a 100 kilowatt system, just looking for recommendations. I'm probably not the best person to talk to. Let's take that offline. So if you want to just shoot an email to training@simpliphipower.com, let me get back to that. We can get y'all hooked up with somebody that can talk through the system and recommendations for different things, as well as just kind of look over the project and help you out. Is it necessary to to use a pre-charging resistor to avoid high short circuit when the inverter charge controller connects the battery for the first time? Depends on the inverter make model, charger maker model, and the size of those two related to the battery bank. It can be possible where I've seen it done where like let's say a 600 volt charge controller, it's got a big capacitor, has a lot of inrush. Sometimes that's not a terrible idea to do, but most of the time it shouldn't be necessary. All right, looks like we're out of questions. I just want to say thank you everybody for joining. Again, we'll send out this presentation with a follow-up that'll have the recording as well as I believe the slides, but feel free to reach out to me anytime at training@simpliphipower.com. Thanks everyone for joining.